In this video, we're going to see an example of creating and using a Java interface. So to create a new interface, I can say new and then interface, and I'll give it a name. I'll call it my interface, and we'll say finish. So an interface can contain constants, and it can also contain abstract methods. And let's make that, actually let's do this. We'll say add, and then we'll also say void greet, and that'll take a string. So here's two abstract methods, and you may say, well, why are these abstract? Because we don't say that they're abstract, but the fact that they're in an interface by default makes them abstract. Now there's some new features in interfaces in recent versions of Java, but for our purposes, we're just going to discuss interfaces as being constants and abstract methods. And you can actually give a default implementation to these methods, but again, for now, we're not going to look at that. Okay, so what good is this interface? So let's create a new class, and we'll call this my class. Again, a very boring name. And notice here we have the option not just to say the superclass, which will be Java-Lang object since we're not using inheritance here, but I can add an interface, and we'll use my interface. And then once I've done that, notice it says implements my interface, indicating that my class is going to implement my interface. And then notice, in addition to the automatically generated constructor, I get two methods that are annotated as override, add, and greet. And notice it gives me a default implementation as well. So for add, I'm not really sure what add is supposed to do here. I didn't really think this through very well, it looks like. So I think what I'll do is I'm going to change this to where this takes a number, and then it'll add some number to that. So you'll notice now my class has an error, and it's because we're missing that variable. Now, one of the fixes isn't, hey, if you add a variable, it'll match. It just notices, hey, this method signature doesn't match anything in that I'm overriding, either from a parent class or from an interface. So do you want me to add this to the interface you're implementing, or let's see, what was the other option? Or do you want me to just say this, we're not going to override this? Well, I'll just add an integer parameter, and now they match up. So let's return with this function, we'll return num plus, and if you'll remember, my interface has a constant, my num, so we'll say num plus my num. And now that works. And then for greeting, we'll just do something simple. So now we've created a class that implements the my interface interface. Now let's create our main method here. I'll just call it interface driver. It's a terrible name, but that's what it is. So close enough. Here's our main method. So we're going to have a my class object, and we'll call it thing. We're not being very creative with our names, but the point here is just to see the interface in the class. So we'll say, if we say thing add, let's say 5, that's going to equal, and then here we'll just call thing add 5. And then we'll say thing greet, and we'll say CSE 205. And for some reason it's not liking this. Because I never So we need to instantiate that. So if we run this, and you can see we have this there. I could, if I wanted, create another class. I'll call it my other class. And it's going to implement my interface as well. But actually, let's not say this specifically. Let's put some methods here first. Let's say, we'll say hello. And that'll just say hello world. And if we go back to our driver, we'll say something else is equal to new my other class. So we'll make a note that we're doing that here. And we'll call something else hello. There we go. So if we run this, and let's put this header here. So we'll say my class thing. And if we run this, you can see here's what my other class does. So let's go into my other class and say that it's going to implement my interface. And you can see I immediately get an error. This must implement the inherited abstract method my interface add, and the other things. So I'm going to click to add all the unimplemented methods, and then I can come in here and I'll just change that to num plus 1, and then I can say something here plus and I'll also print my secret number here. I think I called it mynum. Can double check. Yep. Okay, so now my other class implements my interface. I have those methods there. And just as I did with thing, now I can say something else, add 5. And I can also say something else, greet. And we need to pass a name here, so we'll say CSE 205, just so we're doing the exact same thing with both objects, and we can see that they handle things differently. So if I run this, you can see my things add. We get 47, hello CSE 240, and then with something else, we have this extra method in that class that doesn't exist in my class, but again, there's two separate classes, but both of them implement the same interface. So both of them have an add method, even though they do completely different things, and they both have a greet method. And again, the greet method is different. They each implement that in their own way, but the method signature is the same. So the point of an interface is it allows us to create commonality between classes that are otherwise unrelated. One of the examples we'll see is we'll revisit our animals class hierarchy, and those animal classes are all related through the animal parent class for things that are related to animals. But we could, in theory, have an interface that dealt with, say, some sort of movement. So we could have a fly interface, and bats are mammals, eagles are birds, mosquitoes are insects, but all three of those fly. So if we had a complicated class hierarchy, yeah, all birds, maybe we'll say that they'll fly, and we'll throw the exceptions in there when we need to. But we could also have an interface called fly that instead of saying, hey, all these animals fly, we could say certain animals that do fly implement that interface. So it just gives us a little bit of more flexibility with how we want to actually implement our class structures.